Let's continue with Chapter 3, Section 1 from your workbook. This is page 50. Here are the definitions that you need for those lines. You can stop the video and copy those down. And now that you have them copied, you'll notice that we didn't say parallel lines in any of these definitions. We kept talking about coplanar lines. Parallel lines are a special case of coplanar lines. For these definitions, it's okay if the two lines that we're intersecting are not parallel. We still can use these descriptions. So let's talk about examples of alternate interior angles. You have two choices for alternate interior. It could be angle 1 with angle 2, or you could choose angle 3 with angle 4. I'll choose 1 and 2. Next is same side interior. You can choose angle 1 with angle 4 because I'm on the same side of the transversal on the interior of these coplanar lines. Or you can also choose angle 3 with angle 2. I'll pick the first ones, 1 with 4. And last, what's an example of corresponding angles in this diagram? You have 4 choices for this one. Let's start on the top right of each intersection. Angle 6 is in the top right, angle 2 is in the top right. Angle 3 is in the bottom right, with angle 8 on the bottom right. Angle 5, top left, angle 4, top left, angle 1, bottom left of the intersection, angle 7, bottom left of this intersection. So I'll choose angle 1 with angle 7 for this example. You have 4 different choices that are all correct. So down here, a 2-column proof is a display that shows the steps to prove a theorem. The first column shows the steps. Whoa. Let's clean that up. That's better. It shows the steps, and the second column shows the reason for each step. Okay, now on to the examples. This diagram shows Lafayette Regional Airport, and now we're back to parallel lines, the special case of the coplanar lines. These 2 black lines are parallel runways. This black line is a transversal runway. So now they want us to compare angle 2 and the angle that's vertical to 1. Well, that means we're talking about angle 2, which is this little corner here, and the angle vertical to 1. I think it's better if I fill it in like this. So those 2 angles are on the interior of the parallel lines, and they're on alternate sides of the transversal. So if you read this through, the angle vertical to 1 is between the runway segments. Angle 2 is between runway segments, but on the opposite side of the transversal runway, because alternate interior angles are by definition not adjacent and lie between the lines on opposite sides of a transversal. These 2 are alternate interior. Moving on to page 51. You can ignore the stuff over here, we just need this diagram a little later. So now, here's the diagram for number 2. We need to find the measures of some of these angles. Well, we've got 2 sets of parallel lines. All we need is 1 set of parallel lines and a single transversal. So we can't think of all of these lines all at once. Now, we need to find the measure of angle 1 and the measure of angle 2. First, we'll notice that 42 degrees is the only angle that has a measurement. Lucky for us, the angle that's measured 42 has a special relationship with angle 1. What is it? They're corresponding.